you are given two numbers, d1 equal to 2i and d2 equal to 2. So what are their sum, difference, product, and ratio? Hi, Assalamualaikum. My name is Dr. Kat. In this lesson, you are going to um, learn about definitions and rules of complex numbers. At the end of this lesson, you will be able to recognize complex numbers and apply rules to solve basic problem involving complex numbers. So let's start. So what is complex numbers? So for example, if you have the set of 4, so the set of 4 can be solved, and the answer would be either positive 2 and negative 2, right? So how about if we want to find out set negative 4? So how to get it? So one of the way how we can get it is we can separate it as a negative 1 times 4 under the square root, and separate it as the multiplication of minus 1 multiplied by set 4, and here we get actually the same from this part, but the negative 1 actually we can represent it as I. This is the origin of the complex number, so that we can get it is either positive 2i and negative 2i. So this I represents a complex number which is differ slightly with a real number. So any complex number can be represented in a standard form, right? Standard form, which is the complex number is the addition of a real number part x plus real part imaginary, which is this y is a real number, but when the real number multiplied by the I, so this whole part is a imaginary part. Okay, so the real part of the complex numbers is x, and the imaginary part of z is y. So a useful property which can help us in the operation involving a complex number is I square equal to minus 1, or actually it comes from this identity. Okay, so in a formula, we can the standard form of complex numbers can be expressed as a plus ib or p plus iq. So this is a real part and this is an imaginary part. Okay, numerically, for example, we can have 2 minus 5i or 3.4 plus 8.7. Sorry, I have some mistake here. This is I. Okay, so in engineering, usually instead of using I, they use J. So it doesn't matter because they are same, they are just a complex number, only they use the imaginary part. Instead of I, they use J. Okay, any other non-standard form of complex numbers can be reduced to the standard form z equal to x plus iy. That means you will see many forms later, and that can be convertible and or can be written in a standard form where z equal to x plus iy. Okay, now we will go to the operation of complex number. Suppose that you are given two complex numbers C1 1 plus 2i and C2 3 minus 4i. So C1 and C2, they are equal only if the um, the real part is equal and the real part is also equal. In this case, they are not equal, so that C1 is not equal to C2. For addition or the sum, so we can separate real part. So that's mean 1 plus 3. So this is the real part. And then uh, plus the imaginary part, so that you will get 4 minus 2i. For the subtraction, same way, that we have to make sure that, okay, so the real part, so the real part 1 minus 3 plus 2 minus 4. Okay, so that means both in sum and difference, you have to make an operation separately for real part and also in imaginary part. Alright, and then for the product of C1 and C2, it is a little bit tricky. That means you have to multiply each part of each complex number. So 1 multiplied by 3 plus 1 multiplied by minus 4i. Okay, and then plus 2i multiplied by 3 and plus 2i multiplied by negative 4i. Alright, so then you will have 4 terms. So these 4 terms, you have to inspect it properly. So you have 3 minus 4i plus 6i minus 8i square. So remember, for the identity of I square equal to minus 1, so that finally you will get the standard form of the complex number 11 minus 2i. So another useful property of a complex numbers is a conjugate. So this conjugate is very useful in division operation. So for example, you are given zi equal to xi plus iyy and z2 x2 plus iy2. So the complex number is the conjugate of the complex number is notated by zi bar above it. Okay, in some field, instead of using bar above it, so some textbook and some field they use, especially in quantum mechanics also, they use the asterisk here. So it represents the conjugate of a complex number. The conjugate of a complex number change in the in front of the imaginary part. So the imaginary part change to the negative of that imaginary part. Okay, so the property of the conjugate of the complex number is, for example, z1 multiplied by the complex by its complex number, so we'll get a real number, where now the I disappear. Okay, that's why it is very useful. Okay, and then the conjugate of the sum of both number can be separated. So you can show it and you can prove it whether this is correct or not. Okay, and then the conjugate of the product is equal to the product of their conjugates. And then the conjugates of the division or ratio is equal to the ratio of their conjugates. And also these are the properties of the conjugate, where the x, okay, so x, for example, z equal to x plus iy. So this is two useful property that can be used in the operation of complex number. Okay, for example, So you are given 1 plus 2i, okay, and 3 minus 4i. So you see C1, the conjugate of it, or can be shown here is a plus. The conjugate is equal to 1 minus 2i. So you see this part become negative for the conjugates. Okay, so from the previous property, the multiplication of a complex number with its conjugate will cause it to have a pure real number. Okay, and then by using the identity here, so you will get finally 4 plus 2i, and the conjugate of the products is equal to the product of their conjugates. So you have to multiply each part. So you will get 4 terms. Sorry, I think I have something wrong here. Okay. So this is actually 6i. Okay. So you will finally 11 minus 2i. Okay, and then these are the ratios, the conjugate of the ratios. So what make it useful is that when you make a division, you can multiply by the conjugate. So this is the bottom terms. So you create another term so that this is equal to 1, right? And then you multiply the below term with its conjugate, because the multiplication of that will give you a complex a real number. So that's why we make this strategy. Then we get 25 here. Finally, you will get the standard form of a complex number. Okay, finally, when you refer back to the teaser in the beginning of the lesson, so now you can get, so this is actually a complex number without a real part, and this is a complex number. We can also say that this is a complex number without imaginary part, which is equal to the real number. So you can just add them because they belong to two different parts. Okay, this is the summation of both term. So the difference whether the d1 minus d2 or d2 minus d1. So they either way they will give you different value. Okay, so the products, so you can just multiply them, so you have a complex number without real part. And then the ratio is like this. So you do not need to conjugate them because it has a only one parts for each number. So you will get only I. Okay, so in the next lesson we will see the complex number in different form rather than the standard form. Okay, bye.